All right, now I want to present an example of a relation. I want to talk a little bit about relations. And again, I'm going to do this with an example. This time I'm going to give you a list of names again. And on the other side, I'm going to give you, I'm not going to list the things in the, well, I guess I could list some of them. But what I want this other set to be, I'm going to draw it like this, is all menu items from a restaurant. So these people go out to dinner to some restaurant, and they're going to order their food. So I want to think of that as a correspondence. When they go to talk to the waiter, I want to think of this as a correspondence between the people and what they order. That's going to be the, so this is food over here. That's the other set. So I could draw a bunch of arrows from here to here like I did before. But what I'm going to do is I'm going to give you the information differently, and then I'm going to draw an arrow diagram so you can see the difference between the function example and the relation example. So what I'm going to tell you is just this data, is that Amy decides to order steak and a salad. Kim decides to order some fish and some stuffed mushrooms because she's really hungry, and even some cake for dessert. And Kelly orders pasta, and she gets some cake. And Jill, well, she's late and doesn't order anything. So that's the information that happens at the restaurant, and now I can give the correspondence with an arrow diagram. So let me do that. So now I'm going to erase this and write some of the things down that I have. I know that this restaurant obviously has steak. It has salad. It has pasta, fish. It has the mushrooms. It has cake. And it may have some other thing like some nachos. It could have some nachos, or it could have ice cream. Right? Dot, dot, dot. Lots of things at this restaurant to order. So let me just draw some arrows. Amy ordered steak and salad. Kim ordered fish, mushrooms, and cake. Kelly ordered pasta and cake. See, I used to be a waitress. This is why I can remember all these. And Jill ordered nothing. So this is a different arrow diagram. This is very different than the arrow diagram we had up before. So let me point out some special properties of the arrow diagram. I can erase that because now I have that information cataloged with arrows, so I don't have to write it in that format anymore. So what's different about this arrow diagram is notice that not everyone, not every name has an arrow coming out of it. And some names have more than one. So these are both different than in the function case. And then there's also, again, the same property. There was this property is in common with the function case, and that is that there are menu items that were not ordered by anyone. Okay? So this is not a function because of these two reasons right here. So it turns out a function is a bunch of arrows from one set to another, and so is a relation. But a function has special properties that a general relation does not have to have. So that's kind of where I want you to be when you look at the challenge and when you look at the notes. I want you to look at, when you're reading the challenge problems, I want you to just think about the difference that I pointed out in terms of arrow diagrams. Because every function you look at, whether it's a formula function or a graph or however you're given a function, which we'll talk a lot more about that in week 2, it turns out if you just draw a few arrows for your arrow diagram, or for your function, you can often see some of these properties pretty clearly. So, I should have kept that there. Oh, there's one more thing I want to write down about relations. So I want to write down one other way of representing the same information that I just erased with the arrow diagram. I could do the following. I'm going to write this down in this way. The same exact information. I'm not going to write them all because it'll take me too long, but let me just put down Kim's fish and Kim's cake, etc. I could write each one of those arrows down instead of drawing an arrow diagram, because if you want to type this into a computer, sometimes it's hard to draw arrows. You can write it down, the same information you can write down this way. You could write name, comma, menu item. And that's just a pair where I've made the convention that I'm always going to put a name in the left and the menu item occurs on the right. And it turns out these pairs will give the same information as the arrow diagram. I'll have exactly the same information as I had before. And for a mathematician, this is actually, in some sense, the best way to define a relation between two sets. So my final word about relations will be a definition that you're going to see in the first week's notes. So this is a real mathematical definition here, and that is that a relation from set A to set B is any collection of ordered pairs where the first comes from A, so ordered means I'm picking this order, and the second comes from B. And then we'll see that a function is one of these with special properties. And that's how I want you to go into the first week challenge and the first week notes.